Welcome to the final video of this section, where we'll be discussing protocol-oriented programming. In this video, we're going to take a look at what protocol-oriented programming is. We'll look at how to use protocols to extend a type, and we'll also demonstrate how to extend a protocol. In an earlier video, we demonstrated some of the important differences between structs and classes, namely how classes are reference types and structs are value types. So, we understand that structs are safer and oftentimes more performant than classes. However, we also discussed a major trade-off when using structs over classes. Unlike classes, structs can't use inheritance, which, of course, is troublesome for extensibility and code reuse. Having said that, we're faced with the challenge of maintaining immutability while having extensibility. Protocols are the answer. But this isn't a one-to-one solution. Protocols are, in many ways, better than traditional inheritance. With inheritance, you can wind up with bloated classes due to being required to implement functions or properties that you don't need to attain your desired functionality. With protocols, you just conform to the functionality that you need. This makes your code leaner and easier to read. At WWDC 2015, Apple, along with a major revision to the Swift language, defined Swift as a protocol-oriented language. This definition could only be made with the advent of certain new language features, specifically protocol extensions, which, as the name implies, gives us the ability to extend protocols. Of course, extensions have long been one of Swift's best features. They allow us to add behavior to existing classes, structs, and enums, including those in the Cocoa framework, giving our applications added functionality with a native feel. And as of Swift 2, we now have the ability to extend protocols. The following protocol has a function definition for a generic shuffle function. Let's go ahead and add it to Swift's array class, which gives array a new shuffle function. This works great, but what if we decided later that we wanted both dictionary and set to have the same functionality? Prior to Swift 2, the only way to do this is to repeat our implementation. As you can imagine, this kind of repeated logic is undesirable and tedious. Fortunately, Swift 2 allows us to extend entire types. For example, if we wanted to extend every class in collection type with our shuffle functionality, we could simply extend collection type itself, and all of the types that conform to collection type will then automatically receive our implementation. Of course, we may not want to extend all of collection type with our shuffle implementation. Fortunately, Apple added another useful component to protocol extensions: type constraints. For example, you may want to limit your extension's functionality to collection types that are comparable. This can be done by utilizing the where clause within your extension definition. In essence, protocol extensions allow us to enhance an entire set of types without tweaking individual subclasses, structs, or enumerations. One could write an entire course on protocols, and while we do utilize protocols later in this course, due to time constraints, we don't dive into as much detail as we'd like to. So having said that, I will be maintaining some useful resources on this video's resource page. In this video, we discuss protocols and extensions and how in combination they can change the way we think about programming entirely. In this section, we covered some of the major language features in Swift, while noting some of the more interesting points like Swift string type, the differences between structs and classes, pattern matching, and more. Finally, we introduced functional and protocol-oriented programming. In the next section, we'll take a more step-by-step approach as we begin our exploration of Swift's advanced language features, while building a functional version of the classic application, Game of Life.